How do feedback systems work in industrial automation? Imagine trying to keep a room at just the right temperature without constantly adjusting the heater. That's what feedback systems do in industrial automation. They help machines and processes stay steady and accurate. When setting up basic automation, understanding how feedback works is key. It's like giving a machine a sense of awareness so it can correct itself when needed. In industrial automation, feedback systems work by constantly checking a process variable. Think of this as the current state of a machine or process, like how hot a furnace is or how fast a conveyor belt moves. Sensors are used to measure this variable. For example, a temperature probe might tell us the current heat level, or a position encoder could tell us where a robotic arm is. Once the sensor measures the process variable, it sends this information to a controller. The controller compares this measurement to the desired value, called the set point. If the temperature is too high or the speed too slow, the controller figures out what needs to be done. It then sends a signal to an actuator, which could be a valve, a motor, or a heater, to make the necessary adjustments. This process happens very quickly, often many times every second. The sensor keeps measuring, the controller keeps comparing, and the actuator keeps adjusting. This cycle creates a loop that keeps the process stable. If something changes unexpectedly, like a sudden drop in temperature, the system reacts immediately to bring it back to the right level. Feedback systems are essential in many parts of industry. They help keep products consistent, improve efficiency, and allow machines to adapt to changing conditions. For example, in a smart factory, a robotic arm uses feedback from position sensors to move precisely. Temperature control in a chemical plant relies on feedback loops to keep conditions within strict limits. Programmable logic controllers are often used as the brains of these systems. They read sensor signals, run control programs, and send commands to actuators. Modern controllers can connect to the industrial Internet of Things, giving operators remote access and data analysis capabilities. While feedback systems are powerful, they do have challenges. Sensors need to be accurate, and signals must be clear of noise. Sometimes, delays in response or nonlinear behaviors can cause issues. That's why tuning the system properly is important to keep everything running smoothly. In the end, feedback systems are the backbone of industrial automation. They allow machines to operate reliably and adaptively, making factories smarter and more efficient. This continuous loop of measurement and correction is what keeps modern industry moving forward smoothly.